Hey everyone, hope you're all doing well. In today's video, I will be talking about primary trigonometric application. So basically, it's just application, but we're going to be using primary trigonometric ratios, which we have learned in grade 10 or grade 9. And yeah, let's get started. So I'll do a couple of example questions, and then you can do some questions on your own. And yeah, so I can just teach you how to apply trigonometric ratios to different application styles. Starting with the first question. So let's break the question down. Let's first read it and then break it down. Marley is standing 5 meters from a flagpole. She observes the angle of elevation of the top of the flagpole or to the top of the flagpole to be 25 degrees. If her eyes are 1.62 meters above the ground, determine the height of the flagpole. Okay, so let's see what we are given. Let's highlight what we're given. So Marley is standing 5 meters from the flagpole. So this value is very important. 5 meters from the flagpole. So that means she is standing away from the flagpole. And we have the diagram here, we just have to label it, right? So she's standing 5 meters away from the flagpole because, as we can see here, it spans from the flagpole to her, like that, right? And so we know that bit of information. Now let's see what else we are given. From a flagpole, she observes the angle of elevation of the top of the flagpole to be 25 degrees. So here's some terminology that you're probably going to need to know is angle of elevation. What is angle of elevation? It's not that hard. Think about it, elevation. So when we're doing trig, we have two things, elevation and depression. Angle of elevation, angle of depression. So an angle of elevation is basically something that looks like this and is going up. Like if somebody's looking up, for example, yeah, it's in like an upward position. Think of like linear, right? Positive slope is going to be going up. And then same, now if we use the same logic with angle of depression looks something like this. So you're looking down, right? So there's going to be an angle here and you're looking down, and same like linear, it's going to be a negative slope. So it's like that. So this would be a depression, and then this would be an elevation, right? And so they're saying she observes the angle of elevation of the top of the flagpole to be 25 degrees, right? And she's observing this from her eyes. And the diagram's already partly given to us. We just have to put what they're telling us in the question onto the diagram, the information we're given. So if it says the flagpole is to be 25 degrees, like her elevation to the flagpole, to the top of this flagpole is 25 degrees. That means from where her eyes are and where she's looking is 25 degrees, like that. And so there's that important information, the angle of elevation to be 25 degrees. And it's saying if her eyes are 1.62 meters above the ground, her eyes are right here, right? And so if they're saying she's 1.62 meters above the ground, then all of this right here will be 1.62. So that means this is also 1.62, right? And don't forget meters. Let me quickly add my units on this one. 1.62 meters. Now, she's 1.62 meters. So again, that's important information. And the overall question wants us to determine the height of the flagpole, right? And so we have to figure out the height of this whole thing right here. And so we'll just label this as height for now. But let's see what we're given. We are actually given part of the height of the flagpole, because remember, this right here, oh wow, that's too much. This right here is 1.62. So we already know some of the length of the flagpole. Now all we have to do is find this much, what I highlighted in blue. So we have to find what this is of the flagpole, and I'll just label that as X because we don't know what it is. And now we know what to solve. We have to solve for X, right? So how do we solve for X? So remember, this right here is a triangle, right? That's a triangle, and it is a right angle triangle, so we can use primary trigonometric ratios. So if we do, then we have to figure out, using SOH CAH TOA, what can we use, right? So we know this part of the triangle right here is 5 meters, because below it is 5 meters, right where the person is to the flagpole. So that distance above also will be 5 meters. So that means our triangle will look something like this. Will be 25 degrees here and 5 meters here. And this is X. So what primary trigonometric ratio can we use? We can use tan. Let me erase this real quick. It's not erasing. Okay, here we go. So we can use tan because remember, the 25 degrees opposite of that is the opposite side. And that's what we have to solve for. So we have to use a ratio that has the opposite side in it, but also has the adjacent, since that's what we're given, right? And then the hypotenuse is, we don't have a value for it, and we're not solving for it. So it doesn't really matter. So we can use tan. So tan theta equals opposite over adjacent. So then it's going to be tan, what's it called, 25 degrees, because that's where our angle theta is, and that's where our reference angle. And so tan 25 equals opposite over adjacent. So opposite is X, adjacent is 5. Now, how do we solve? We have to isolate for X. And like if we isolate for X, we have to do it like BEDMAS. So we'll multiply both sides by 5. So then we're left with 5 times tan 25 equals X. And now all we do is plug this into our calculator. Let me see what we get. 5 times tan 25 is X equals 2.331 whatever. So then X is going to be approximately 2.3, right? And now that we know what X is, we have enough information to figure out the height, because remember, the height is also part of the height of the flagpole is 1.62 meters. So we actually have to do X plus 1.62 equals H. And then what does X equal? 2.3 plus 1.62 equals H. So let me quickly do that. 1.62. So we are left with as the height equals 3.9515 ... And then I'll just round it to 4. So the flagpole is around 4 meters. And that's all you have to do for this question. That's all there is. And they're not that complicated. Most styles of primary trigonometric applications follow the same style. So you can just apply that same rule that you do with every question to the next question. What you're solving for will probably change, but they're along the same lines. So let's move to this one. This one's a little bit more complex. And we have the diagram given. And so we can read the question and apply what the question gives us onto the diagram. So let's see what is in here. So a building DF. Okay, so we know that DF right here is going to be this building, because D is there. D is right here, and F is right here, right? And a tower CE, okay, so CE is going to be this right here, because right, this is going to be the tower CE, because again E is right here and C is right there, right? Okay, now, and they say the building and the tower are 94 meters apart. Okay, so, oh, this already has it, the diagram. So you see it's 94 meters apart, right? As we can see right here, it's labeled. So that both of the buildings are 9 meters apart. Okay, that's good. And from the roof of the building of the, well, wait, from the roof of the building, the angle of elevation to the top of the tower is 15 degrees. And that is why here, this 15 degrees is right here, because it's saying from the top of the building, right? So DF, this building right here, from the top of that, the angle of elevation, meaning it's going to go upwards, it's going to be like looking up to the top, will be 15 degrees, right? And then that's why they labeled that 15 degrees. So then, well, give me a second. There we go. And the angle of depression to the bottom of the tower is 46 degrees. So we're still at the top of the building, right? We're still at the top of this building right here. And now it's saying the angle of depression to the bottom of the tower is 46 degrees. And remember, angle of depression, again, looks like this. And elevation looks like this, right? So there's really few ways angle of depression can look. Angle of depression can look like this. It can look like this. And angle of elevation can look like this or like this, right? It's just in an upwards position. Angle of depression is in a downwards position, just like in the word depression, down, and elevation going up. So then that's why, so yeah, the bottom of the tower is 46, so that's the angle of depression right there. And then there's 46. And now they want us to find the height of the tower. So they want us to find the height of, give me a second, let me erase this. They want us to find the height of this whole thing. I'll label it as H. So how do we do that? So we know that we can use primary trigonometric ratios. So what we have to do is actually solve for this part. Let me get my highlighter. Oh, this would be very helpful. We have to solve for this, and we have to solve for, get another color, this, right? So for the red and for the purple, we have to solve that like missing side length. So we'll label those right now as we'll call it X and A, right? And so now we can apply trigonometric ratios to solve it. So with this 94 at the bottom, that's very important, because that tells us this triangle that I want to take out, right? This triangle, when we take it out and I draw another diagram of how it's supposed to look, it's going to look like this. So this, and again, you don't have to do this step, it's just better to show visually to you guys. So then this will be 46 degrees, and then this side length right here, that side length will actually be 94. Because remember, this 94 at the bottom, when we take it up, is the same distance. They're the same distance apart, right? And so that will help us figure out the height. Now, so that's 94, and again, this is X, because we have to solve for that. So now, what trigonometric ratio can we use? We can use if you go through SOH CAH TOA, we can use tan, because if we use tan, it will be tan 46. I'm jumping a few steps here, but tan 46 equals the opposite. Again, opposite is what we're solving for, so x over, and then the adjacent, which we have, is 94. So then if we isolate it, it's going to be tan 46 equals x over 94, multiply both sides by 94, so we're left with 94 times tan 46 equals x. So let's plug that into our calculator. 94 times tan 46 will give us x will equal 97.339 whatever, and I'll just round it to 97.3. And then don't forget our units, meters. Oh, did I put units for this one? Yeah, I did. 4 meters. Okay, so we're not done yet, because we still have to solve for a, because that's still part of the height. Because remember, height is going to be a plus, oh my gosh, multiplication, a plus x, right? And so to figure out a, again, if we draw the other triangle like this, oh, my bad. If we draw the other triangle, right? Because remember, this is the second triangle. Let me get a highlighter. This is the second triangle right here, right? And so now, if we do label it, this will be 15, right? This will still be 94, because this distance stays constant, right, when we're looking at these applications, and this will be a. And what can we use again? We can use tan, because we're solving for the opposite and we're given the adjacent. So it's going to be tan 15 equals a over 94, multiply both sides by 94, so left with 94 times tan 15 equals a equals, let's do it, 94, plug that into your calculator, tan 15, and we're left with 25.1870, whatever, and then round that to the nearest hundredths, so 25.19, I guess, yeah. And then now, again, to figure out the total height, we have to do height equals 97.3 plus 25.19. And then let me do it real quick. 97.3 plus 25.19. That will give us 122.49. I'll just round that to nearest tenths. 122.5, and then meters. So then 122.5 meters is your final height for the tower. And that's basically how you would solve it. Not that bad. Sometimes these questions can take a little bit of imagination, but it's not that bad. And then that's basically it for that. The next page, I have another question. And what you're also going to be learning how to do is also drawing the diagrams. So doing questions, but you're not given the diagram, right? And so we'll do that now too, how to solve a question not given a diagram. So a helicopter hovers directly over a landing pad on top of a 125 meter high building. So let's break that up. That's very important. Over a landing pad on top of a 125 meter tall building. So it hovers. So it's not on top of the building. It's on, like, it's, you know, on top of the building, but it's not landed on it, right? So it's not directly on the building, but it's over the building. So here's the building. Here's the building. Wow. Let me quickly. This is the building, right? Here's the small pad. And then they said to us the building is 125 meters tall. So this is 125 meters tall, and the helicopter hovers directly over the building. Let's see if I can draw a helicopter. Oh my. Okay, guys, that's my helicopter. So it hovers directly over the building, right? And the angle of elevation of the helicopter from a point 145 meters from the base of the building is 56. Okay, let's break that up because it might be confusing to some of you. So there's a point, to simplify, there's a point 125 meters away from the building, and specifically from the base of the building. So we know that this point is going to be from the base, but it's going to be a 90-degree angle from the base of the building, right? Because it's directly from the base, right? And it's 145 meters away. So this point is right here, and it's 145 meters away. And from that point, there's an angle of elevation to the helicopter. So to this helicopter, there's an angle of elevation from that point. So let's quickly draw that. Right? Just like that. And so the angle of elevation is right here, 56 degrees. And now they say, how high is the helicopter above the landing pad? So let's zoom in a bit. So they want us to find how high the helicopter is from the landing pad. So we know the building is 125 meters tall, and we know we have to figure out this distance, that distance. Oh wow, that looks bad. We have to figure out this distance, right? Because that's where the helicopter is, and we don't know what that distance is because it's hovering over the building. So we'll label that as X. So we have to find this part right. Wow. We have to find this part right there. Well, that's X, and we have to find that part. Now, what can we do? We are given the angle of elevation and the 145 meters from the base. And we are given the 125 meters. So now we just label this whole thing H. Okay, that whole thing is H, right? And so we can just use simple primary trigonometric ratios to solve for H. So we can just use tan, because remember, if we draw the triangle, let me draw the triangle. So if we draw the triangle like this, right? Here is 56, here is 145, here is H. We have to solve for H, and that's the opposite side, because directly opposite is the opposite side. So we can use tan. So it's going to be tan 56 equals the H value over 145. Now, all we have to do is multiply both sides by 145. So that's going to be 145 times tan 56 equals H. So then let me do it real quick. 145 times tan 56. That's going to be around 214.9713 right? So H equals 214, and then I'll just do 97, because some teachers, I just realized some teachers, they don't want you to round too early and then at the end you round, right? Because I could round that to 215 probably right now, but we'll just wait till the end. So we're given 215. So we know H is 215. So we know the whole height, including the helicopter hovering over the building, is 214. So what can we do to figure out that this X value right here by itself? We can actually do 214.97 minus 125. Because remember, that 125 is part of the overall height. So it's part of the 214.97. So if we just minus it from that, we'll get what X is. Will equal X. So if we do it, 214.97 minus 125 equals x equals 89 point, wow, that they both look like 9. That's crazy. 89.97, and then meters. So I'll round that now. So x equals 90 meters. And that's what your height will be. So the plane, so if we write a therefore statement, I have no, oh, I do have room. Wow, okay. So therefore, that's it. You solve the question, just like that. And again, you have to draw the diagram for that one, which can be a little tedious sometimes, but you have to use your imagination. And this is the last question. I'll leave it for you guys to do. This right here, that word that I'm underlining right now is elevation. Keep that in mind. And yeah, you guys try the question and I'll solve it right now. I have finished the question and I realized there was a little spelling, or not spelling, more of like a, yeah, like a comprehension type of error. So I forgot to write, what is the angle of what is the angle of elevation of the ladder to the wall? I didn't write to the wall, right? Some people may assume it was to the wall, but I wrote that now just in case if you didn't know. And so here's the answer now. I'm showing it. This is the answer. I wrote a little explanation, and this red part right here is just the ladder that I wanted to represent. And that's basically it. I hope you learned a lot about primary trigonometric application. I hope you enjoyed today's video and learned a lot about primary trig application. And make sure to subscribe, like, and share the video. And hope you have a great rest of your day, evening, night, or whatever time it is for you. Bye. Take care.